thinking that you guys probably have most of these slides like early on in this, like the slides, yeah. So these are very similar slides, if not the same slides that you've been looking at in the lecture. So some of you have seen them, some of you haven't, so I'm just going to kind of touch on them. The special electrons are called valence electrons. They're in the highest N, okay? And so like in the test you just took, where it said NS2, NP2, how many valence electrons were there? There were 4, yep, exactly. These are the outermost. These are when atoms join together. These are the electrons, let no man put us under. No, when atoms join together, these are the electrons that are going to do the sharing or the transferring. Okay, so here's the first thing if you want to. On your periodic table I just gave you. Well, no, don't do that. We're getting close. Okay, I'm sorry. 1A has 1 valence electron. 2A has 2 valence electrons. 3A has 3 valence electrons, and these would be the main group elements. How do well, these are all main group elements. Okay, rare gases. How many valence electrons do they have?
8.
8. Very good. They have 8. Perfect. Okay, so we're going to be dealing with ions. We have ions that are made from one atom. Ions made from one atom are called monoatomic. Mono makes sense. And then we're going to be dealing with things that are ions, but they have more than one atom that make them up. Here's one for you. I bet if I put NO3, does anybody know the name of that? Nitrate. Yes, this is nitrate. How many atoms are there in nitrate?
4.
4, exactly. For nitrate, this is an example of a polyatomic ion. What's the charge of nitrate? -1. Perfect. Okay, and if you're like, I'm not sure what she's talking about, that's okay, we'll get there. But that's just an example of a polyatomic ion. Okay? Right. So monoatomic ions is what we're actually going to start with part 1. One atom that makes an ion. Now, the thing about an ion is the number of electrons is that it has buzzing outside the nucleus is not the same as the number of protons it has in the nucleus. That off balance makes it charged. If it's negatively charged, does it have more or less electrons than protons? It has more electrons. Yep, if it's negatively charged, it has more electrons than protons. Okay? So if it's, we call that an anion. It's negatively charged. Okay? It has more electrons. What about a cation? What makes a cation? It has less electrons. Yep. It's positively charged. It has less electrons. Okay. I'll go ahead and tell you the way this works. We're going to see that if I put M, well, I'll just go ahead and tell you. If you see M, I mean metals. Metals tend to form cations. Metals tend to form cations. Metals tend to lose some electrons. So what do you think nonmetals form? Anions. Yep, I don't have anything fancy for nonmetals, so I'll just put NM for nonmetals. They tend to form anions. So under my M plus, my metals, I'm going to put lose electrons. And under my nonmetals, I'm going to put gain electrons. It's nice when there are patterns in science. And that's definitely a pattern in science. And we'll talk about why the metals lose electrons and the nonmetals gain electrons. So now this might be where you, okay. What I would tell students is for this 1A, this entire group, and you don't have to circle it, but at the top there, I would put a +1. Why? Because all of those metals, right, form a +1 cation. What type of ion do the 2A form?
+2.
A +2, very good. Now I'm going to skip the group B elements. I'm going to go over here to 3A. I'm going to go under my JAG because only under my JAG is where I'm interested right now because that's my metals. what do the 3A metals form? Yeah, I've only got 2 listed up there, but I think they all form a +3. So I'm going to go ahead and put under aluminum a +3. Very good. Those numbers +1, +2, +3, I use the phrase hang your hat on it. I don't know why. I don't know where that came from. Hang your hat. To me, hang your hat means a for sure, for sure. You can hang your hat on these guys. And then what I do is I take the periodic table, I skip the rare gases. The thing about the rare gases is they're pretty happy with their 8 electrons. Okay, let's go to the 7A. What's the name for the 7A elements? Do you remember? Halogens, very good. And what charge do they form? A -1. So a lot of times I would put a -1 here. How about going then farther to the left? What do the 6A form? -2. Now when I say the 6A form, I'm talking about the what? The non-metals here, aren't I? And over here I was talking about the metals. Okay, and then what about the 5A? -3, exactly. Perfect.
What about carbon there?
And the thing about carbon is I can't hang my hat on it doing, it's going to do something, but I can't hang my hat on what it's going to do.
And my other question, underneath that column 3A, underneath the aluminum and the other 2, what about those other items down there underneath those stair steps there?
Yeah, that would be indium and
not just those, but I mean all the others underneath there.
Okay, these guys, I'm thinking +3 for this guy. +3 for this guy. Now, what was your question?
All the other ones underneath that stair step.
These guys, where I'm doing that is actually, I'm going to go ahead and I'm going to draw it because where there's an X through it, I don't know. You can't hang your hat on it. Oops, you cannot hang your hat on it. Sort of. I have an exception coming up in part 2. Okay?
I know they're transition metals, but they're still metals.
They have different oxidation states, and so you have to kind of deduce from the formula what oxidation state it is, what cation it is. Okay. So, except for 3 of them. And actually, these next few slides do what we just talked about. 1A, 2A, 3A, metals, you guys told me a +1, a +2, and a +3. And here we go. That's all this slide is showing you. Are we good with that? The non-metals, 5A, 6A, and 7A, what did we say they would form? What charges? Yep. -3, -2, -1, exactly. And they're listed right here. Okay? So when students say, oh my gosh, I have to memorize that chlorine forms a -1 monoatomic ion. No, you don't. You just got to have your periodic table. Find it in 7A. Okay. So now one thing I didn't mention, and I know I mentioned it in my slides, so I'm going to go ahead and try to kind of have it make sense here. So you guys would tell me these guys are special. They have a complete octet. They are very special. So the reason why, for instance, the 7As, for instance, pick on chlorine, forms a -1 is it picks up 1 electron to get 8 electrons. It still has the heart of a chlorine atom, but now it picked up 1 electron. Now instead of 17 electrons, it has 18 electrons, 8 valence electrons, and that's why it's -1. So what does, for instance, then phosphorus tend to do? It tends to pick up 1, 2, 3 electrons, and now it becomes like the rare gas 18, which is argon, with regard to its electrons. It has the heart of a phosphorus atom, and it has 3 extra electrons. Exactly. If we want to look at the these guys over here, well, the metals lose electrons. If we want to pick on, for instance, strontium, Notice strontium has 38 electrons. If it keeps the heart of a strontium atom, if it loses 2 electrons, it will become like 36. If it loses 2 electrons, now I'm looking at my thing here. If it loses 2 electrons, it will become like what? Krypton, exactly. And in losing 2 electrons, now it becomes positively charged 2. That's how those all work that we just said you can hang your hat on. Okay. So today, what you guys need to be able to do is 2 things. For ionic compounds, well, it's so fun, by the way. Remember, they don't still make them for kids, but they used to be called granimals. Like, where you go to your closet and you can pick a shirt, you can pick a pants. And that's, to me, that's what ionic compounds are. You pick a cation, you pick an anion, your choice, something that's positively charged, negatively charged, and you make an ionic compound out of it. It's wonderful. Okay, and today you're going to have to be able to make the formula for that, and you're going to have to name it. For instance, tell me if you can, I know you can, table salt. What's the formula for table salt? NaCl. Cool. Look at your periodic table and tell me what ion, positive or negative, and what magnitude sodium forms. +1. Does everybody see where she got that from? Mm-hmm. How about chlorine? -1. Chlorine's a -1? Cool. Well, you guys told me it's got this relationship, 1 Na, 1 Cl. That's perfect. And do you see where in doing that, we have, let's see how we're going to do this. You have made a neutral formula unit. For instance, you took one of your +1, sodium, plus one of your chlorines, -1, and it's 0. That's what neutral means. Okay, and we're going to be talking more about that. So is that where I talk about this? Well, let me go ahead and just finish that thought, if that's okay with you. Let's go to our closet. This is so exciting. And instead of sodium, let's pick barium. So what sort of charge do we have? +2, and I want to combine it with chlorine again. That's -1. Now, if I just wrote the formula BaCl, that's not neutral, because I have 1 +2 charge, and I have 1 -1 charge. I'm getting a +1 out of that, right? That's not neutral. My favorite way to write the neutral formula unit is to what I call crisscross. And sometimes this works for students, sometimes it doesn't. But by crisscrossing, basically you rewrite your formula, and how do I do this? The number of bariums you need is the magnitude, not the charge, the magnitude of your anion. So the number of cations you need is the magnitude you have on your anion. So that's my crisscross, that's my 1. And the number of anions you need is the magnitude on your cation. So that's my 2. Crisscross. Okay. Now let's see what we got. I've got 1 barium, you told me +2. I've got 2 chlorines, you told me -1. Yeah, that's neutral. So that's how you crisscross and get the formula for the ionic compound with that cation and that ion, given those charges. You'll get some workout at doing that here in a minute. But you see where I have gone ahead and it's writing a chemical formula of a compound. Now, granted, this looks a little far away, and sometimes students might fuss. They're like, Mrs. Snipes, do I have to put a 1 there? No, but if you want to put a 1, you can. Okay, BaCl2 is probably how you see it written. I want to put a 1. I'm cool with that. Okay. All right, let's take a look at this. So you guys told me sodium chloride is NaCl. If you use that as your kind of model, that'll work just fine. Because it's always the cation, like sodium, and it's the anion, which is going to be what, the non-metal, chlorine anion, okay, is written last. We'll get to this in the third part, but like your nitrate, your NO3, actually is NO3 with a -1 charge. If you need more than one of them, and I think you guys might have run into this in the Sodium nitrate, wait, that's not a good example. Barium nitrate, how's that? Barium +2, nitrate, NO3 -1. Actually, we're not going to get this to like the third part. But if I crisscross, how many bariums do I need? 1 barium. And then how many NO3s do I need? I need 2. And so what that's saying is if I need 2 NO3s, I have to put NO3 in parentheses, and then as a subscript outside the parentheses, put a 2. Okay, so that's all that's saying. Cool. All right, so I have some examples here. Crisscrossing. Magnesium is 2A, so you guys would have a +2 at the top of that column, so that's where that +2 cation comes from. Halogen, the chlorine's a halogen, so the 7A is -1, so that's where that comes from. Notice that if you crisscross, you do go ahead and this works. Crisscrossing works here. That's the neutral formula of what's called barium chloride, and we'll talk more about those names here in a minute. This is an example of a polyatomic, most polyatomic ions like nitrate. All this is nitrate in disguise. NO3- instead of NO3-, it's NH4+, NH4+1. It's called ammonium. Okay. Use it all the time. So if we crisscross, notice that I need what? 2 ammoniums, so that's why there's a subscript there, 2 there, and I only need 1 CO3 group. And notice, and if you feel better putting CO3 in parentheses because it's polyatomic, I'm fine. Even though you only need 1 of them, I'm fine. Okay, but usually it's just written just like that. We'll talk more about that in part 3. Okay, so 2 things you need to do. One is, I call it the crisscross, make the neutral formula from a cation and anion. And then the other is this, it's the naming part. So this, again, is only for ionic compounds. Okay, and you got to be able to name them. So you name it as it's written, the cation and the anion. You just, like you guys told me, this is sodium chloride. Now I need to kind of, it's not sodium chlorine, and we'll talk about that. Okay, but it's sodium chloride. So the name of the cations, and actually this is where we're diverging a little bit with our with part 1 and part 2 in here. The name of the metal, if the metal is, where's my thing here? Remember I said you can hang your hat on 1A, 2A, and 3A metals? If the metal is one of those, all it is the name. Now you guys told me this is sodium chloride, and you're right. It's just sodium because sodium is right there. Barium, we did barium nitrate. It's just barium because it's right there. The first name is just barium. We also have 3 kind of sneaky transition elements that only form one type of cation. And so if you want to, on those periodic tables, please find silver, zinc, and cadmium on the periodic table I gave you. And they're kind of clustered together, aren't they? They kind of make a backwards L. And for zinc, if you would put a +2, that would be great. And for cadmium, put a +2. And then for silver, put a +1. So when I say hang your hat, you have to include those 3 stragglers also. They're always that charge. And since their charge is always known, we don't have to say what charge they are. If your metal is anything other than these, you have to say what charge it is. Okay, and we'll get to that. Okay. Naming the monatomic. Okay, the anions. So that would be what, the nonmetals, right? So these guys over here, the nonmetals. What you saw with chlorine is we kind of dropped the INE, we locked off the INE and replaced it with an IDE. So instead of chlorine, it's chloride. So sodium chloride. Cation anion. Okay. So do you guys have these? I didn't put bills in here. Good. So you already have this up here, where in your notes. These are all those non-metals that you lop off the end and replace with IDE. And yes, you're going to want to know those. All right, whew, ready for part one. Now I meant to, but I think I'm okay. I meant to print me off one of like what you guys have. But what I'd like to do for each of these parts is to pick one to kind of show you how it works. So can you turn to, so keep going. What page is it? It's after all that blah blah. 11.8? 11.8? That's what you're looking for. Nope, keep going. That one right there.
11.11.
11.11. 11.11. So it's got two parts. The first part is the component ions, the second part is the name. So for instance, let's pick on E. So does yours look like this? For 11.11, it looks like E. Goodness, my pen doesn't want to work. You have Mg plus 2, and you should be able, if I gave you Mg, you should find it in 2A, know it's plus 2. And then the other component ion is P3 minus, yeah, or minus 3. Yeah, and you see already that I kind of, I go 2 plus, plus 2, 3 minus, minus 3. It's the same thing for me. If I crisscross, what is the neutral formula going to look like? How many mg's do I need? 3. Very good. Now don't forget to make that a subscript. So next to this, you're going to put mg3. How many phosphoruses do I need? 2. Make it a subscript. Perfect. Now let's go ahead and name this. So for each of these in part A, you got or the first part, you need to name it. So what's the first name of this? Magnesium. Yep. And, you know, lowercase, uppercase, I don't care. Now, from phosphorus, what would it be? Not phosphate. What did we do? The phosphide. Exactly. IDE. Phosphide. Yep. Perfect. All right. So let's look at one in the bottom there. How about potassium nitride? Let's look at D down there. So for the second one, the first name is potassium. I can never spell potassium. Nitride. Okay, so now we need to write the component ions. What's the symbol for potassium? Okay, cool. So what is the charge for it? Plus 1. I'm liking it. Very good. Okay, what about nitride? What's the symbol? I think I heard N. Yep. And then what's the charge? You use your periodic tables. -3. Very good. Now let's crisscross. Perfect. So how many K's do I need? I need 3. I'm liking it. How many N's do I need? Just 1. Now you can put the 1 or you can just leave it like that. Okay? So I'll give you a few minutes to go ahead. I don't encourage you to work at the second part. I think we should try to stay together. We're doing good for time. Cation. So for those metals that can commonly form 2 or more stable cations, what you have to do is you need to indicate which ion it is. You need to indicate which cation it is. There are 2 ways to do this. We're just going to indicate in Roman numerals the charge. There's an alternative way, and I think I have the list coming up here. So, when do you use or not use Roman numerals? Well, you don't use Roman numerals on anything we used for the first part in here. So you do not use Roman numerals for these metals. You don't use Roman numerals for these metals. You don't use Roman numerals for these metals. And you don't use Roman numerals for the 3 special guys that I had you circle, which I'm reading this upside down. These guys right here. You do not use Roman numerals. So however you want to get that in your mind, or get that on your sheet, or whatever, you don't use Roman numerals. For every other metal, so the metal's always going to be the cation. For every other cation metal, you have to say what charge it is. So, here then I guess I'll do it this way. I'm going to draw marks through everything that you don't need to use Roman numerals for. No Roman numerals, okay? No Roman numerals. For everything that doesn't have a mark through it, you have to use Roman numerals. Now, granted, some of these metals, I don't have the different cations they form, but let's just assume that they can have different plus charges. Cation forms, oxidation states, they can have different plus charges. So you'll have to say which one it is in Roman numerals. And I'll show you kind of what that looks like. Actually, I have it right here. Now, these aren't all of the possibilities, but for instance, Fe stands for what? Yep, for iron. So iron can have at least 2 oxidations or 2 different forms. It can be +2 or +3. And I'm going to focus on this way of naming it. So do you see if it's a +2, you actually, in the first name, you use the Roman numeral 2 to show it's a +2. Use the Roman numeral 3 to show it's a +3 cation. Okay. Tin, what's the symbol? Well, symbol for tin is SN, yep. So you can have a tin +2 and it'd be tin Roman numeral 2. You can have a tin +4 and it would be Roman numeral 4. Now here's the problem I'm running into with you new whippersnappers coming through, is y'all don't know your Roman numerals. Sometimes. So somewhere in the margins you might want to do, of course that's Roman numeral 1, Roman numeral 2, Roman numeral 3. So what's Roman numeral 4?
I5.
IV. What's Roman numeral 5?
V.
V. Roman numeral 6? VI. Roman numeral 7?
VII.
VII. Yeah, you're doing good. Roman numeral 8?
VIII.
VIII. Roman numeral 9?
IX.
IX. Perfect. Roman numeral 10?
X.
X. Okay, so probably you're going to want to kind of at least 1 through 4 know your Roman numerals. Okay. So here we have some other ones. And I know Ryan asked if you use these alternate ones, these old-timey ones, I can cross-reference. But I would use these to indicate the charge. Okay, so let's do a couple examples. First off, which three transition elements do you not use Roman numerals for?
Silver, zinc, and cadmium.
Yep, silver, zinc, and cadmium. Perfect. And they're all kind of clustered together. What charge is silver? +1. Plus or +1. Perfect. So, in this next part, it's kind of, all it is the cation that you're going to have to struggle with a little bit. So let's take a look at E in the first part. So E in the first part looks like this. Our component ions are Fe2+ and Cl- or -1. If I crisscross, how many Fe's do I need? We're on part 2E. Part 2E. So go back to, yeah, right there. 2E. How many Fe's do we need?
2.
We need 2 Fe's if we crisscross?
No.
Just need 1. Yep. How many chlorines do we need if we crisscross? 2. We need 2. Cool. So, what's the first name of this cation? Iron 2. It goes back to, it doesn't go to how many you have, it goes back to the charge. So iron, or ferrous, yep. Iron 2 is the way I would go. And then what's the last name? Chloride. Perfect. Yep. Let's take a look at something down at the bottom there. How about, let's go for F down there at the bottom. So in this case, you're given the name, you have to write the component ion and crisscross. So I have nickel, can't spell nickel. Oh goodness. Nickel 3 oxide. So what is the component's cation? What's the symbol for nickel? Ni, perfect. And then what's the charge? Oops, go back. You don't know, Ryan?
I don't know.
If it's nickel 3 oxide, what's the charge?
+1. +3.
Yep, it's a +3. So we're going to get that from the Roman numerals. How about oxygen? What's the charge, or oxide? It is -2 because it's 6A. So if we crisscross, how many nickels do we need? 2. Very good. And how many oxygens do we need?
3.
3. Yep. So go ahead and do that part. Atomic ion thing. Remember I said if you crisscross, you need more than one nitrate, you had to put NO3 in parentheses, and then down below it, you have to say how many of those you need. We're going to kind of focus on that. Now this, if you guys can find this in your background, your right stuff, I think that would be good. Now, if here's the whole page, I'm going to write something down here that I think you should write on yours too. If you want to put a star up here, say memorize, you can. Okay?
Do we have to memorize this?
I love that part of this job. Yes.
No.
Memorize.
Why would you? That's
I would
terrorizing.
be like this.
Okay, I told you to add something. First off, are these negatively charged or positively charged?
Negative.
They are negatively charged. Where is nitrate?
Positive?
No, on here.
Oh, on the end.
Yes, see how it's organized is you find nitrogen. These are the polyatomic ions for nitrogen. Yep, there's nitrate. So these are negatively charged anions. Now, there are 2 cations. Cations. There are 2 polyatomic cations, and they are coming up here in a minute, and they go like this. First off, NH4 plus. What's the name of that? It is ammonium. Yes. Not to be confused with NH3, which is ammonia. So this is AMMONIUM. That's the ammonium cation. The other polyatomic cation drives me nuts, and I apologize in advance, but it is this one where we have, what's Hg stand for? What element?
Mercury.
Mercury. Very good. Well, this is a polyatomic cation, Hg2, 2 plus. Now, the name for it is mercury. Sorry, that's the word mercury. Roman numeral 1. Now, you might say, well, Hg2, 2 plus, that looks like just 2 monoatomics put together. No. Just as nitrate is stuck together, here's nitrate, there's NO3. It all runs around with a -1 charge. You would tell me that that's NO3, okay? Just that, so that is nitrate. Also, this guy down here has Hg bonded to an Hg, 2 mercury atoms all running around with a +2 charge. Not my problem, yours. This stuff sticks together. It's a polyatomic ion. Now, the reason they call it mercury 1, as far as I can tell, is because we have an oxidation state of +1 and +1 for these individual ones. It's my least favorite polyatomic ion. Now, over here, I've written something on the board. It says flashcards, ion flashcards. I did this last year, and it was so much fun. I'm going to do it again. Some assembly required. I'm going to go ahead and hand them out. If you don't end up using them, feel free to give them back to me or use them as scratch paper. But you can kind of see they have some things. The thing I don't like about these is they have things that you don't have to memorize. Flashcards you should use to memorize. So for instance, what is the charge of sodium? +1. Do you have to memorize that?
Probably.
Look it up on the table. I wouldn't memorize it. I would just look it up on the table. I think it'd be kind of silly, but you're going to find it actually in here. Okay? So no, and then we put that together. There's kind of some silly ones here. You know what I'm saying? So anyway, for 10 extra credit points, and then you can, as it says over there on the left, you can take these. What you do is you cut along the solid line, and then you bend along the dotted line. Isn't that adorable? And then you can secure it with either tape or a staple. And then you have on both sides. You have the.
This is an opportunity to delegate. Let's see if we're-
You can delegate. Yes, you can. Okay.
Of course, all three, I got a 16-year-old do it.
Now I do have some hints on. Yeah, I don't have you memorize much because I'm not a memorizer, you know. But I do have some hints. So here are a few hints. So for instance, I told you that most of them are negatively charged. The positively charged ones I had you put on hopefully that sheet. Ammonium, NH4 plus 1, mercury 1, Hg2, 2 plus. Most of them have oxygen. There are some exceptions, and I have the exceptions written down here. Under, I think it is carbon, you'll find cyanide, Cn-1, thiocyanate, SCN-1, triiodide, 3 iodine, iodine atoms joined together with a -1 charge collectively. Oh, yeah, these are the hints. Now also, polyatomic ions, a lot of them end in ite and ate. And again, I shouldn't tease about it, but, well, let's put it this way. What is the ending for the chlorine monoatomic anion? What's the ending? Chloride, perfect. I-D-E. Okay, that was part 1 and actually part 2. If it's just one atom, it ends in I-D-E. Now, you're going to have to struggle a little bit with I-T-E. In fact, sometimes I feel a little bit rude because I'm like, now was that iodite or iodide? You know, they are two different anions. I-D-E is one atom. I'm going to show you here in a minute a bunch of ites and ates. Okay, ites and ates have oxygen with them. Okay, let's look at some ites and ates. Okay, if you find, I'll grab mine. If you go back to this sheet, okay, if you look under sulfur for this sheet, you're going to find some stuff. Under sulfur for this sheet, you're going to find that sulfur combines with oxygen in 2 different ways. What's the charge for these both ways, though? It's -2 for both of them, yeah. So at least that's one thing we have going for us. It shares the same charge. Yeah, different numbers of oxygen. Now there's kind of a sort of a way to kind of differentiate between ite and ate within the same element. And I used to say you ate too much, so ate is too much oxygen. So ate is always more oxygen than ite. So relative to sulfur, sulfate is more oxygen, SO4, and sulfite is less oxygen, SO3. Same pattern here with nitrogen. Now the number of oxygens change. Cool thing over here with nitrogen, again, they're both -1, but you'll have nitrogen combining with 2 oxygens, nitrogen combining with 3 oxygens. The 3 oxygen is you ate too much oxygen. Okay, so you're going to need to know that. Then if you go to, what's the name of the group 7A elements? Halogens, yep. If you go to the halogens, they kind of have an interesting pattern over there. Chlorine, bromine, and iodine all kind of have this set of oxyanions, we call them. So smack dab in the middle, they combine with 1 oxygen, 2 oxygens, 3 oxygens, and 4 oxygens. So right here, whoops, sorry, go back. Right here, well, it's not letting me do that. Right here, you've got your ite and ate, okay, with 2 and 3, and that's going to be the same thing for bromine and iodine. But if it has a little bit oxygen, then the ite, we put a prefix in front of it. So if you're extra low on your thermal energy, you're hypothermic. Okay, good. So hypo ending in ite means even less oxygen than the ite. Okay, so hypochlorite would be around chlorine, less oxygen than chlorite, so instead of 2, it's 1. So for 8, again, we use a prefix, the per. So again, this pattern works for chlorine, bromine, and iodine. So here we have, instead of 8, we have, so it ends in 8, but instead of 3, we have 4, so we add the prefix per, so it's perchlorate. Notice, do they all have the same charge? Yeah, -1. Do the other halogens follow this pattern? Yeah. Okay, so yeah, hopefully that helps. Another little hint I'm going to tell you within the cluster again is we have some polyatomic ions that pick up a hydrogen. Every time they pick up a hydrogen, the charge goes down 1. Okay, so here are some examples. Around sulfur, we have sulfite, which is SO3 2-. We kick in a hydrogen. We now call it hydrogen sulfite. And notice, what does the charge do? It went down by just 1, exactly. We have the same thing with sulfate. We have hydrogen sulfate or bisulfate, either name. Carbonate, hydrogen carbonate or bicarbonate. Now for phosphate, it gets exciting. I'm easily entertained. For phosphate, actually, the fact that it begins with a -3, once we kick in 1 hydrogen, we now call this hydrogen phosphate. And now it goes from a -2 to from a -3 to a -2. Actually, there's one more polyatomic ion because we can kick in 1 more hydrogen, and now that kicks the negative down from a -2 to a -1. We call this is the only place in nomenclature in this class you get to use the prefix Di, which of course stands for 2. This is the only place you get to use di. Dihydrogen phosphate just means it's H2PO4. Means it's the only place you get to use the word di, or the other stuff. Okay, so again, this is kind of what you're going to want to memorize, and feel free to, I look forward to, let's make the whole flashcards thing, you can have to a week from Friday if you want to. But the other thing for extra credit I'm going to show you, I'll go ahead and show you now. Okay, so any questions about flashcards? Now the extra credit would go for assignment points. Your other opportunity, and I'll go ahead and hand this out now. Your other opportunity looks like this. So this is what I call the ionic compound worksheet. So you can do this if you want, and you can read what your options are right there. So you can either use this to replace a homework, or you can turn it in for 10 points extra credit. So I kind of like this to replace your homework because it's nice and concise. I know. So nice and concise. It is 2 sides. Now, yeah, let me know. This would be 2 Friday. Yeah. Do you want me to make this due later? Do you want a little bit more time? No, because it has to do your part this week's. Yeah.
So if we want to you, like, because I don't ever come here and send one, so we just take a picture or like scan it.
Yes, you can just take a picture of it. Yeah, that definitely makes sense. Yep.
And then you can just submit it in that, and this week's assignment.
Yep, perfect. I'm liking that.
So everybody's gonna see our selfie?
What?
So everybody's gonna see.
No, your selfie would be, yeah, there's a good question about selfie. You can go ahead and do your selfie as part of your, like if you do the flashcards and take a picture, you can just submit it in any Dropbox, like your homework Dropbox, or you can email it to me as an attachment. Or drop by and show it to me. You can show it to me next Wednesday, because that's not due until, yeah, so you can show it to me. Take a picture. Yeah.
Take a picture of the flashcards. I'm thinking take a picture of me.
Let's take a look right quick
Who wants that?
I'm going to do it over here instead of, because I can't find my stylus. It went somewhere. Let's look at the next part. All right, so how about let's go with F. F on the first part. So F on the first part looks like this. Component ions, Ni 2+, that's the cation. The anion is this HSO4- or -1. Okay, what is the, let's see what I'm gonna do first. Let's crisscross. So how many nickels do I need?
1.
Just 1, perfect. And then how many HSO4s do I need? 2, perfect. Now this is an example where if I need 2 HSO4s, I'm gonna put HSO4 in parentheses. I'm gonna put the 2 as a subscript outside. And I'm gonna go ahead and erase that that 1 for now, if that's okay with you. All right. So what's the first name of this thing? Nickel 2. I'm liking it. Any questions about that? Nickel 2 or the other name, but. And then what is the last name?
Bisulfite.
Bisulfite, I would probably call hydrogen sulfide. Or bisulfite, same thing. Okay, let's take a look at the last page. Dun, dun, dun.
Wait, there's a back.
Yep. The last page. Let's see. How about let's do J on the last page. Okay, the name is iron 2, Roman numerals 2, hydroxide. Okay, so what is the cation? Fe, yep, plus 2, very good. Okay, so someone find what's hydroxide?
OH.
OH, yep, hydroxide is different than hydride. Hydroxide is OH, what's the charge? Negative, -1, yep. So that's one of the flashcards, hydroxide. So if we crisscross, how many FEs do I need?
1.
I just need 1, perfect. And then if we crisscross, how many OHs do I need?
2.
I need 2. So in order to get 2, I'm going to have to put OH in parentheses and put a 2 as a subscript outside.
Why?
Why not? Well, okay, so I need 2 OHs, you told me. Now if I don't do parentheses, look at this. If I don't do parentheses, I've got, instead of 2 OH groups, I have basically water, H2O. Yep.
Very simple.
So I have to do this. Actually, I did that on purpose because a lot of times students, yeah, that one's a hard one to recognize when you parentheses for. All right, I'm turning y'all loose. When you're done, come, let me take a look and then you'll be free to go. Free as a bird.